This is going to be a quick video going over how we solve exponential, but very specific here. This is going to focus just on how we use our solving techniques with word problems. So we had a couple of equations that we used in class. We had the growth and decay model, we had the compound interest formula, and we had the compounded continuously, or APERT. So what we're going to do here is we're going to use those three formulas that we started working with in the beginning of the chapter and have us use our solving techniques from the end of the chapter to figure out these equations. So the first thing you want to do is you want to read the problem and make sure you're using the correct equation. So when you look at this first one, you see that you're investing money and we are compounding our interest quarterly. So what that tells me is we are using the longer compound interest formula, which is this formula. You want to plug in everything that you know. You know that you're starting with $1,200. Your interest rate is 4%, so you want to write it as 0.04. Compounded quarterly means 4 times a year, and then your exponent is going to be 4 times t, or 4 times x. We want to set it equal to 3,000 because that's what we want to figure out how long it takes to get to $3,000. Now you remember earlier in the chapter the way we did this is we did it completely with our calculator. We did it visually. We graphed our model, we graphed the amount of money we were trying to get to, we adjusted our window, and we wanted to see where they intersect. In these problems you will specifically be asked to not use the intersection button. Not that you can't use it as a way to check your work, but you have to show that you can do it by hand to get credit on your test. First thing you want to do is figure out what you have in parentheses. So figure out what 1 plus 0.04 divided by 4 is. It is 1.01. And then the next step is you want to get that exponential piece by itself. So we're going to divide both sides by 1,200. So we're going to take 3,000 divided by 1,200. So we get 2.5 equals 1.01 to the 4x power. Now we want to take a log of both sides. The base I want to use is this number, so it's going to be log base 1.01. You'll have in these word problems some very different logs, some different bases, a lot of decimals. On the left, the only way to figure that out is change a base, so you'll take the natural log of 2.5 divided by the natural log of 1.01 using your calculator. So natural log of 2.5 divided by the natural log of 1.01. Getting 92.086. Common mistake is for students to say that's the final answer. It's going to take almost a little over 92 years. But keep in mind, that's not what x equals. It's what 4x equals. So your last step is to divide then your answer by 4 to get x by itself. So you already have it in your calculator. You can hit divided by 4. It's going to take just over 23 years, almost exactly 23 years. So 23.022 years. Now, if you want to check your work with your calculator, then you definitely can. Graph your model in line in 1 in y sub 1, graph 3,000 in y sub 2, adjust your window to make sure you're including up to and exceeding 3,000, and see where they intersect. But to get credit, you need to show me that you can go through the process by hand. Hopefully, using the calculator will help you catch any mistakes that you may have made along the way. The second one is also in a compound interest one, but what's different about this one is it says compounded continuously, which we know is the special case when we use the APERT formula. These problems should be a little faster. You have a lot less to work with, and you should be able to get to your answer quicker, not do quite as much computation. We're going to plug in everything we know. We know we're starting with 3,000. Our interest rate is 2.5%, so 0.025. And we want to triple our money, so we want to get to $9,000. First thing I'm going to do is divide by 3,000 to isolate the exponential piece. So we get 3 equals e to the 0.025x. Next, I want to take log on both sides. This time I'll be taking the natural log of both sides because I'm working with base e. Great thing about working with natural logs is you don't have to do a change of base. It's already something that you can figure out just by using your calculator. The natural log of 3, go to our calculator, is 1.099. That will equal, on the right side, the natural log and e will cancel. We get 0.025x. Divide both sides by 0.025, and again, you already have it on your calculator screen, so you can just right away hit divided by 0.025. Get 43.944 years. So almost 44 years. Again, if you want to check your work when you're done, you can graph your model in line y sub 1, you can graph 9,000 in y sub 2, you can adjust your window and see where they intersect, and it should happen just under 44 years. Another thing to think about when you finish these problems is look at your answer and see if it's logical, see if it makes sense. For example, if you're doing a problem like this and your final answer says it's going to take 1,000 years to triple your money, then something went wrong because that doesn't make sense. On the other side, if you do a problem like this and it says you're going to double your money next year, that's also not very logical. That doesn't make sense. So look at two things. Look at the visual to see if it matches with your work, and look at the logical side of it and see, does your answer make sense in the given situation. If you can do problems like this, then you can do any of the word problem applications, both just plugging in and being able to solve.